हेलो एवरीवन, वेलकम बैक टू माय चैनल। तो अब हम देखने वाले हैं एनसीईआरटी इकोनॉमिक्स क्लास 12 का, जिसमें आज हम देखेंगे चैप्टर 2 जो कि है थ्योरी ऑफ कंज्यूमर बिहेवियर। तो शुरू करते हैं हमारा आज का चैप्टर। In this chapter, we will study the behavior of an individual consumer. The consumer has to decide how to spend her income on different goods. Economists call this the problem of choice. Most naturally, any consumer will want to get a combination of goods that gives her maximum satisfaction. What will be this best combination? This depends on the likes of the consumer and what the consumer can afford to buy. The likes of the consumer are also called preferences, and what the consumer can afford to buy depends on prices of the goods and the income of the consumer. This chapter presents two different approaches that explain consumer behavior. First, cardinal utility analysis, and second, ordinal utility analysis. We shall use the term goods to mean goods as well as services. Preliminary notations and assumption. A consumer in general consumes many goods, but for simplicity, we shall consider the consumer's choice problem in a situation where there are only two goods, bananas and mangoes. The assumption that there are only two goods simplifies the analysis considerably and allows us to understand some important concepts by using simple diagrams. Any combination of the amount of the two goods will be called as consumption bundle, or in short a bundle. In general, we shall use the variable x1 to denote the quantity of bananas and x2 to denote the quantities of mangoes. X1 and x2 can be positive or 0. X1 x2 would mean the bundle consisting of x1 quantity of bananas and x2 quantities of mangoes. For particular values of x1 and x2, that means x1 and x2 would give us a particular bundle. For example, the bundle 510 consists of 5 bananas and 10 mangoes. The bundle 105 consists of 10 bananas and 5 mangoes. Utility. A consumer usually decides his demand for a commodity on the basis of utility or satisfaction that he derives from it. What is utility? Utility of a commodity is its want satisfying capacity. The more the need of a commodity or the stronger the desire to have it, the greater is the utility derived from the commodity. Utility is subjective. Different individuals can get different levels of utility from the same commodity. For example, someone who likes chocolates will get much higher utility from a chocolate than someone who is not so fond of chocolates. Also, utility that one individual gets from the commodity can change with change in place and time. For example, utility from the use of a room heater will depend upon whether the individual is in Ladakh or Chennai, or whether it is summer or winter time. Cardinal utility analysis. Cardinal utility analysis assumes that level of utility can be expressed in numbers. For example, we can measure the utility derived from a shirt and say, this shirt gives me 50 units of utility. Before discussing further, it will be useful to have a look at two important measures of utility. Measures of utility. Total utility. Total utility of a fixed quantity of a commodity, TU, is the total satisfaction derived from consuming the given amount of some commodity X. More of commodity X provides more satisfaction to the consumer. TU depends on the quantity of the commodity consumed. Therefore, TUN refers to total utility derived from consuming n units of a commodity X. Marginal utility. Marginal utility is the change in the total utility due to consumption of one additional unit of a commodity. For example, suppose 4 bananas gives us 28 units of total utility and 5 bananas gives us 30 units of total utility. Clearly, consumption of the fifth banana has caused total utility to increase by 2 units. 30 units minus 28 units. Therefore, marginal utility of the fifth banana is 2 units. MU5 equals to TU5 minus TU4 equals to 30 minus 28 equals to 2. In general, MUN equals to TUN minus TUN minus 1, where subscript n refers to the nth unit of the commodity. Total utility and marginal utility can also be related in the following way. TUN equals to MU1 plus MU2 plus MUN minus 1 plus MUN. This simply means that TU derived from consuming n units of bananas is the sum total of marginal utility of first banana MU1, marginal utility of second banana MU2, and so on, till the marginal utility of the nth unit. Table number 2.1 and figure 2.1 shows an imaginary example of the values of marginal and total utility derived from consumption of various amounts of a commodity. Usually, it is seen that the marginal utility diminishes with increase in consumption of the commodity. This happens because having obtained some amount of the commodity, the desire of the consumer to have still more of it becomes weaker. The same is also shown in the table and graph. Table 2.1 Values of marginal and total utility derived from consumption of various amounts of a commodity. Figure 2.1 The value of marginal and total utility derived from consumption of various amounts of a commodity. The marginal utility diminishes with increase in consumption of the commodity. Notice that MU3 is less than MU2. You may have also noticed that total utility increases but at a diminishing rate. The rate of change in total utility due to change in quantity of commodity consumed is a measure of marginal utility. This marginal utility diminishes with increase in consumption of the commodity from 12 to 6, 6 to 4, and so on. This follows from the law of diminishing marginal utility. Law of diminishing marginal utility states that marginal utility from consuming each additional unit of a commodity declines as its consumption increases, while keeping consumption of other commodities constant. Mu becomes zero at a level when Tu remains constant. In the example, Tu does not change at fifth unit of consumption and therefore Mu5 equals to 0. Thereafter, Tu starts falling and Mu becomes negative. Derivation of demand curve in the case of a single commodity. Law of diminishing marginal utility. Cardinal utility analysis can be used to derive demand curve for a commodity. What is demand and what is demand curve? The quantity of a commodity that a consumer is willing to buy and is able to afford, given prices of goods and income of the consumer, is called demand for that commodity. Demand for a commodity X apart from the price of X itself depends on factors such as prices of other commodities, income of the consumer, and taste and preferences of the consumers. Demand curve is a graphic presentation of various quantities of a commodity that a consumer is willing to buy at different prices of the same commodity while holding constant price of other related commodities and income of the consumer. Figure 2.2 presents hypothetical demand curve of an individual for commodity X at its different prices. Quantity is measured along the horizontal axis and price is measured along the vertical axis. The downward sloping demand curve shows that at lower prices the individual is willing to buy more of commodity X. At higher prices, C is willing to buy less of commodity X. Therefore, there is a negative relationship between price of a commodity and quantity demanded, which is referred to as the law of demand. An explanation for a downward sloping demand curve stressed on the notion of diminishing marginal utility. The law of diminishing marginal utility states that each successive unit of a commodity provides lower marginal utility. Therefore, the individual will not be willing to pay as much for each additional unit, and this results in a downward sloping demand curve. At a price of rupees 40 per unit X, individuals' demand for X was 5 units. The sixth unit of commodity X will be worth less than the fifth unit. The individual will be willing to buy the sixth unit only when the price drops below rupees 40 per unit. Hence, the law of diminishing marginal utility explains why demand curves have a negative slope. Ordinal utility analysis. Cardinal utility analysis is simple to understand but suffers from a major drawback in the form of quantification of utility in numbers. In real life, we never express utility in the form of numbers. At the most, we can rank various alternative combinations in terms of having more or less utility. In other words, the consumer does not measure utility in numbers, though he often ranks various consumption bundles. This forms the starting point of the topic ordinal utility analysis. A consumer's preferences over the set of available bundles can often be represented diagrammatically. We have already seen that the bundles available to the consumer can be plotted as 2 points in a two-dimensional graph. The points representing bundles which give the consumer equal utility can generally be joined to obtain a curve like the one in figure 2.3. The consumer is said to be indifferent on the different bundles because each point of the bundle gives the consumer equal utility. Such a curve joining all points representing bundles among which the consumer is indifferent is called the indifferent curve. All the points such as A, B, C, and D lying on an indifference curve provide the consumer with the same level of satisfaction. It is clear that when a consumer gets one more banana, he has to forego some mangoes so that her total utility level remains the same and she remains on the same indifference curve. Therefore, indifference curve slopes downward. The amount of bananas that the consumer has to forego in order to get an additional banana, her total utility level being the same, is called the marginal rate of substitution (MRS). In other words, MRS is simply the rate at which the consumer will substitute bananas for mangoes so that her total utility remains constant. So MRS equals to del y by del x bar. Del y by del x equals to del y by del x if y by del x greater than equals to 0 equals to minus del y by del x if del y less than del x by del x equals to 0. MRS equals to del y by del x means that MRS equals only the magnitude of the expression del y by del x. If del y by del x equals to minus 3 by 1, it means MRS equals to 3. One can notice that in the table 2.2, as we increase the quantity of bananas, the quantity of mangoes sacrificed for each additional banana declines. In other words, MRS diminishes with increase in the number of bananas. As the number of bananas the consumer increases, the MU derived from each additional banana falls. Similarly, with the fall in quantity of mangoes, the marginal utility derived from mangoes increases. So, with increase in the number of bananas, the consumer will feel the inclination to sacrifice small and smaller amounts of mangoes. This tendency for the MRS to fall with increase in quantity of bananas is known as law of diminishing marginal rate of substitution. This can be seen from figure 2.3 also. Going from point A to point B, the consumer sacrifices 3 mangoes for 1 banana. Going from point B to point C, the consumer sacrifices 2 mangoes for 1 banana. And going from point C to D, the consumer sacrifices just one mango for one banana. Thus, it is clear that the consumer sacrifices smaller and smaller quantities of mangoes for each additional banana. Shape of an indifference curve. It may be mentioned that the law of diminishing marginal rate of substitution causes an indifference curve to be convex to the origin. This is the most common shape of an indifference curve. But in case of goods being perfect substitutes, the marginal rate of substitution does not diminish. It remains the same. Let's take an example. Perfect substitutes are the goods which can be used in place of each other and provide exactly the same level of utility to the consumer. Representation of law of diminishing marginal rate of substitution. Here the consumer is indifferent for all these combinations as long as the total of 5 rupee coins and 5 rupee notes remain the same. For the consumer, it hardly matters whether she gets a 5 rupee coin or a 5 rupee note. So, irrespective of how many 5 rupees note she has, the consumer will sacrifice only one 5 rupee coin for a 5 rupee note. So, these two commodities are perfect substitutes for the consumer, and indifference curve depicting this will be a straight line. In the figure 2.4, it can be seen that consumer sacrifices the same number of 5 rupee coins each time he has an additional 5 rupee note. Monotonic preferences. Consumers' preferences are assumed to be such that between any two numbers x1, any two bundles x1 and x2 and y1, y2, if x1, x2 has more of at least one of the goods and no less of the other goods compared to y1, y2, then the consumer prefers x1, x2 to y1, y2. Preferences of this kind are called monotonic preferences. Thus, a consumer's preferences are monotonic if and only if between any two bundles the consumer prefers the bundle which has more of at least one of the goods and no less of the other goods as compared to the other bundle. Indifference map. The consumer's preferences over all the bundles can be represented by a family of indifference curves. As shown in figure 2.5, this is called an indifference map of the consumer. All points on an indifference curve represent bundles which are considered indifferent by the consumer. Monotonicity of preferences imply that between any two indifference curves, the bundles on the one which lies above are preferred to the bundles on the one which lies below. Features of indifference curve. Indifference curve slopes downwards from left to right. An indifference curve slopes downwards from left to right, which means that in order to have more of bananas, the consumer has to forego some mangoes. If the consumer does not forego some mangoes with an increase in number of bananas, it will mean consumer having more of bananas with same number of mangoes, taking her to a higher indifference curve. Thus, as long as the consumer is on the same indifference curve, an increase in bananas must be compensated by a fall in quantity of mangoes. Higher indifference curves gives greater level of utility. As long as marginal utility of a commodity is positive, an individual will always prefer more of that commodity, as more of the commodity will increase the level of satisfaction. Consider the different combination of bananas and mangoes, A, B, and C, depicted in table 2.4 and figure 2.7. Combination A, B, and C consist of same quantity of mangoes but different quantities of bananas. Since combination B has more bananas, then A, B will provide the individual A higher level of satisfaction than A. Therefore, B will lie on a higher indifference curve than A, depicting higher satisfaction. Likewise, C has more bananas than B. Quantity of mangoes is the same in both B and C. Therefore, C will provide higher level of satisfaction than B and also lie on a higher indifference curve than B. A higher indifference curve consisting of combination of more of mangoes or more of bananas or more of both will represent combination that gives high level of satisfaction. Two indifference curves never intersect each other. Two indifference curves intersecting each other will lead to conflicting results. To explain this, let us allow two indifference curves to intersect each other as shown in the figure 2.8. As shown, as points A and B lie on the same indifference curve, IC1 utilizes derived from combination A and combination B will give the same level of satisfaction. Similarly, as point A and C lie on the same indifference curve, IC2 utility derived from combination A and from combination B, a combination C will give the same level of satisfaction. From this, it follows that utility from point B and from point C will also be the same. But this is clearly an absurd result, as on point B the consumer gets a greater number of mangoes with the same quantity of bananas. So consumer is better off at point B than at C. Thus, it is clear that intersecting indifference curves will lead to conflicting results. Thus, two indifference curves cannot intersect each other. The consumer's budget. Let us consider a consumer who has only a fixed amount of money or income to spend on two goods. The prices of the goods are given in the market. The consumer cannot buy any and every combination of the two goods that she may want to consume. The consumption bundles that are available to the consumer depend on the prices of the two goods and the income of the consumer. Given her fixed income and the prices of the two goods, the consumer can afford to buy only those bundles which cost her less than or equal to her income. Budget set and budget line. Suppose the income of the consumer is M and the prices of bananas and mangoes are P1 and P2 respectively. Price of a good is amount of money that the consumer has to pay per unit of the good she wants to buy. If rupee is the unit of money and quantity of the good is measured in kilograms, the price of banana being P1 means the consumer has to pay P1 rupees per kilograms of banana that she wants to buy. If the consumer wants to buy X1 quantities of bananas, she will have to spend P1 X1 amount of money. Similarly, if the consumer wants to buy X2 quantities of mangoes, you will have to spend P2 X2 amount of money. Therefore, if the consumer wants to buy the bundle consisting of X1 quantities of bananas and X2 quantities of mangoes, she will have to spend P1 X1 plus P2 X2 amount of money. She can buy this bundle only if she has at least P1 X1 plus P2 X2 amount of money. Given the prices of the goods and the income of a consumer, she can choose any bundle as long as it costs less than or equal to the income she has. In other words, the consumer can buy any bundle X1 X2 such that P1 X1 plus P2 X2 less than equals to M. The inequality 2.1 is called the consumer's budget constant. The set of bundle available to the consumer is called the budget set. The budget set is thus the collection of all the bundles that the consumers can buy with her income at the prevailing market prices. Example. Consider for example a consumer who has rupees 20 and suppose bought the goods are priced at rupees 5 and are available only in integral units. The bundles this consumer can afford to buy are 00, 01, 02, 03, 04, 10, 11, 12, 132021223031 and 40. Among these bundles, 04132231 and 40 cost exactly rupees 20 and all the other bundles cost less than rupees 20. The consumer cannot afford to buy bundles like 33 and 45 because they cost more than rupees 20 at the prevailing prices. If both the goods are perfectly divisible, the consumer's budget set would consist of all the bundles x1, x2 such that x1 and x2 are any numbers greater than or equal to 0 and p1 x1 plus p2 x2 less than equals to m. The budget set can be represented in a diagram as in figure 2.9. The goods considered in example 2.1 were not divisible and were available only in integer units. There are many goods which are divisible in the sense that they are available in non-integer units also. It is not possible to buy half an orange or one-fourth of a banana, but it is certainly possible to buy half a kilogram of rice or one-fourth of a liter of milk. All bundles in the positive quadrant which are on or below the line are included in the budget set. The equation of the line is P1x1 plus P2x2 equals to M. The line consists of all bundles which cost exactly equal to M. This line is called the budget line. Points below the budget line represent bundles which cost readily less than M. The equation 2.2 can also be written as x2 equals to M by P2 minus P1 by P2 x1. In school mathematics, you have learned the equation of a straight line as y equals to c plus mx, where c is the vertical intercept and m is the slope of the straight line. Note that equation 2.3 has the same form. The budget line is a straight line with horizontal intercept m by p1 and vertical intercept m by p2. The horizontal intercept represents the bundle that the consumer can buy if she spends her entire income on bananas. Similarly, the vertical intercept represents the bundle that a consumer can buy if she spends her entire income on mangoes. The slope of the budget line is minus P1 by P2. Price ratio and the slope of the budget line. Think of any point on the budget line. Such a point represents a bundle which costs the consumer her entire budget. Now suppose the consumer wants to have one more banana. She can do it only if she gives up some amount of the other good. How many mangoes does she have to give up if she wants to have an extra quantity of bananas? It would depend on the prices of the two goods. A quantity of banana cost P1, therefore she will have to reduce her expenditure on mangoes by P1 amount if she wants one more quantity of bananas. With P1, she could buy P1 by P2 quantities of mangoes. Therefore, if the consumer wants to have an extra quantity of bananas, when she is spending all her money, she will have to give up P1 by P2 quantities of mango. In other words, in the given market conditions, the consumer can substitute bananas for mangoes at the rate P1 by P2. Derivation of the slope of the budget line. The slope of the budget line measures the amount of change in mangoes required per unit of change in bananas along the budget line. Consider any 2 points x1, x2 and x1 plus del x1, x2 plus del x2 on the budget line. It must be the case that p1 x1 plus p2 x2 equals to m and p1 x1 plus del x1 plus p2 of x2 plus del x2 equals to m. Subtracting 2.4 from 2.5, we obtain P1 del x1 plus P2 del x2 equals to 0. By rearranging terms in 2.6, we obtain del x2 by del x1 equals to minus P1 by P2. Delta is a Greek letter. In mathematics, del is sometimes used to denote a change. Thus, del x1 stands for a change in x1 and del x2 stands for a change in x2. The absolute value of the slope of the budget line measures the rate at which the consumer is able to substitute bananas for mangoes when she spends her entire budget. The absolute value of a number x is equal to x if x greater than equals to 0 and is equal to minus x if x less than 0. The absolute value of x is usually denoted by mod x. Changes in the budget size. The set of available bundles depends on the prices of the two goods and the income of the consumer. When the price of either of the goods or the consumer's income changes, the set of available bundles is also likely to change. Suppose the consumer's income changes from M to M dash, but the prices of two goods remain unchanged. With the new income, the consumer can afford to buy all bundles X1 X2 such that P1 X1 plus P2 X2 less than equals to M dash. Now the equation of budget line is P1 X1 plus P2 X2 equals to M dash. Note that the slope of the new budget line is the same as the slope of the budget line prior to the change in the consumer's income. However, the vertical intercept has changed after the change in income. If there is an increase in the income, that means if M dash greater than M, the vertical as well as the horizontal intercepts increases. There is a parallel outward shift of the budget line. If the income increases, the consumer can buy more of the goods at the prevailing market prices. Similarly, if the income goes down, that means if M dash less than M, both intercepts decrease and hence there is a parallel inverse shift of the budget line. If income goes down, the availability of goods goes down. Changes in the set of available bundles resulting from changes in consumer's income when the prices of the two goods remain unchanged are shown in figure 2.10. Now suppose the price of bananas change from P1 to P1 dash, but the price of mangoes and the consumer's income remain unchanged. At the new price of bananas, the consumer can afford to buy all bundles X1 X2 such that P1 dash X1 plus P2 X2 less than equals to M. The equation of the budget line is P1 dash X1 plus P2 X2 equals to M. Equation 2.10 can also be written as x2 equals to m by p2 minus p1 dash by p2 x1. Note that the vertical intercept of the new budget line is the same as the vertical intercept of the budget line prior to the change in the price of bananas. However, the slope of the budget line and horizontal intercept have changed after price change. If the price of bananas increases, that means if P1 dash greater than P1, the absolute value of the slope of the budget line increases and the budget line becomes steeper. It pivots inward around the vertical intercept and horizontal intercept decreases. If the price of banana decreases, that means P1 dash less than P1, the absolute value of the slope of the budget line decreases and hence the budget line becomes flatter. It pivots outward around the vertical intercept and horizontal intercept increases. Figure 2.11 shows change in the budget set when the price of only one commodity changes, while the price of the other commodity as well as income of the consumer are constant. A change in price of mangoes when price of bananas and the consumer's income remain unchanged will bring about similar changes in the budget set of the consumer. तो ये है इसका ग्राफ. Optimal choice of the consumer. The budget set consists of all bundles that are available to the consumer. The consumer can choose her consumption bundle from the budget set. But on what basis does she choose her consumption bundle from the ones that are available to her? In economics, it is assumed that the consumer chooses her consumption bundle on the basis of her taste and preferences over the bundles in the budget set. It is generally assumed that the consumer has well-defined preferences over the set of all possible bundles. She can compare any two bundles. In other words, between any two bundles, she either prefers one to the other or she is indifferent between the two. Equality of the marginal rate of substitution and the ratio of the prices. The optimum bundle of the consumer is located at the point where the budget line is tangent to one of the indifference curves. If the budget line is tangent to an indifference curve at a point, the absolute value of the slope of the indifference curve (MRS) and that of the budget line price ratio are same at that point. Recall from our earlier discussion that the slope of the indifference curve is the rate at which the consumer is willing to substitute one good for the other. The slope of the budget line is the rate at which the consumer is able to substitute one good for the other in the market. At the optimum, the two rates should be the same. To see why, consider a point where this is not so. Suppose the MRS at such a point is 2 and suppose the two goods have the same price. At this point, the consumer is willing to give up 2 mangoes if she is given an extra banana. But in the market, she can buy an extra banana if she gives up just 1 mango. Therefore, if she buys an extra banana, she can have more of both the goods compared to the bundle represented by the point, and hence move to a preferred bundle. Thus, a point at which the MRS is greater, the price ratio cannot be the optimum. A similar argument holds for any point at which the MRS is less than the price ratio. In economics, it is generally assumed that the consumer is a rational individual. A rational individual clearly knows what is good or what is bad for her, and in any given situation she always tries to achieve the best for herself. Thus, not only does a consumer have well-defined preferences over the set of available bundles, she also acts according to her preferences. From the bundles which are available to her, a rational consumer always chooses the one which gives her maximum satisfaction. In the earlier section, it was observed that the budget set describes the bundles that are available to the consumer, and her preferences over the available bundles can usually be represented by an indifference map. Therefore, the consumer's problems can also be stated as follows. The rational consumer's problem is to move to a point on the highest possible indifference curve given her budget set. If such a point exists, where would it be located? The optimum point would be located on the budget line. A point below the budget line cannot be the optimum. Compared to a point below the budget line, there is always some point on the budget line which contains more of at least one of the goods and no less of the other, and is therefore preferred by a consumer whose preferences are monotonic. Therefore, if the consumer's preferences are monotonic for any point below the budget line, there is some point on the budget line which is preferred by the consumer. Points above the budget line are not available to the consumer. Therefore, the optimum, most preferred bundle of the consumer would be on the budget line. Where on the budget line will the optimum bundle be located? The point at which the budget line just touches is tangent to one of the indifference curves would be the optimum. To be more precise, if the situation is as depicted in figure 2.12, then the optimum would be located at the point where the budget line is tangent to one of the indifference curves. However, there are other situations in which the optimum is at the point where consumer spends her entire income on one of the goods only. To see why this is so, note that any point on the budget line other than the point at which it touches the indifference curve lies on the lower indifference curve and hence is inferior. Therefore, such a point cannot be the consumer's optimum. The optimum bundle is located on the budget line at the point where the budget line is tangent to an indifference curve. Figure 2.12 illustrates the consumer's optimum at x1, x2. The budget line is tangent to the black colored indifference curve. The first thing to note is that the indifference curve just touching the budget line is the highest possible indifference curve given the consumer's budget set. Bundles on the indifference curves above this, like the gray one, are not affordable. Points on the indifference curves below this, like the blue one, are certainly inferior to the points on the indifference curve just touching the budget line. Any other point on the budget line lies on a lower indifference curve and hence is inferior to x1, x2. Therefore, x1, x2 is the consumer's optimum bundle. Demand. In the previous section, we studied the choice problem of the consumer and derived the consumer's optimum bundle given the prices of the goods, the consumer's income and her preferences. It was observed that the amount of good that the consumer chooses optimally depends on the price of the good itself, the price of other goods, the consumer's income, and her taste and preferences. The quantity of commodity that a consumer is willing to buy and is able to afford, given prices of goods and consumers' tastes and preferences, is called demand for the commodity. Whenever one or more of these variables change, the quantity of the good chosen by the consumer is likely to change as well. Here we shall change one of these variables at a time and study how the amount of the good chosen by the consumer is related to that variable. Demand curve and the law of demand. If the prices of other goods, the consumer's income, and her taste and preferences remain unchanged, the amount of a good that the consumer optimally chooses becomes entirely dependent on its price. The relation between the consumer's optimal choice of the quantity of a good and its price is very important, and this relation is called the demand function. Thus, the consumer's demand function for a good gives the amount of the good that the consumer chooses at different levels of its price. When the other things remain unchanged, the consumer's demand for a good as a function of its price can be written as x equals to f of p. Function. Consider any two variables x and y. A function y equals to f of x is a relation between the two variables x and y such that for each value of x, there is an unique value of the variable y. In other words, f of x is a rule which assigns an unique value y for each value of x. As the value of y depends on the value of x, y is called the dependent variable and x is called the independent variable. Example. Consider for example a situation where x can take the values 0, 1, 2, 3 and suppose corresponding value of y are 10, 15, 18 and 20 respectively. Here y and x are related by the function f equals to y equals to f of x, which is defined as follows. f0 equals to 10, f of 1 equals to 15, f of 2 equals to 18 and f of 3 equals to 20. Example 2. Consider another situation where x can take the values 0, 5, 10 and 20 and suppose corresponding values of y are 100, 90, 70 and 40 respectively. Hence, y and x are related by the function y equals to f of x, which is defined as follows. F of 0 equals to 100, f of 10 equals to 90, f of 15 equals to 70 and f of 20 equals to 40. Very often, a functional relation between the two variables can be expressed in algebraic forms like y equals to 5 plus x and y equals to 50 minus x. A function y equals to f of x is an increasing function if the value of y does not decrease with increase in the value of x. It is a decreasing function if the value of y does not increase with increase in the value of x. The function in example 1 is an increasing function, so is the function y equals to x plus 5. The function in example 2 is a decreasing function. The function y equals to 50 minus x is also decreasing. Graphical representation of a function. A graph of a function y equals to f of x is a diagrammatic representation of the function. Following are the graphs of the functions in the examples given above. Usually in a graph, the independent variable is measured along the horizontal axis and the dependent variable is measured along the vertical axis. However, in economics, often the opposite is done. The demand curve, for example, is drawn by taking the independent variable price along the vertical axis and the dependent variable quantity along the horizontal axis. The graph of an increasing function is upward sloping and the graph of the decreasing function is downward sloping. As we can see from the diagrams above, the graph of y equals to 5 plus x is upward sloping and that of y equals to 50 minus x is downward sloping. Where x denotes the quantity and p denotes the price of the good. The demand function can also be represented graphically as in figure 2.13. The graphical representation of the demand function is called the demand curve. The relation between the consumer's demand for a good and the price of the good is likely to be negative in general. In other words, the amount of a good that a consumer would optimally choose is likely to increase when the price of the good falls, and it is likely to decrease with a rise in the price of the good. Deriving a demand curve from indifference curves and budget. Consider an individual consuming bananas x1 and mangoes x2, whose income is M, and market prices of x1 and x2 are P1 and P2 respectively. Figure A depicts her consumption equilibrium at point C, where she buys x1 and x2 quantities of bananas and mangoes respectively. In panel B of figure 2.14, we plot P1 against x1, which is the first point on the demand curve for x1. Suppose the price of x1 drops to P1 bar with P2 and M remaining constant. The budget set in panel A expands and new consumption equilibrium is on higher indifference curve at point D, where she buys more of bananas x1 bar greater than x1 Thus, demand for bananas increases as its price drops. We plot P1 bar against x1 in panel B of figure 2.14 to get the second point on the demand curve for x1. Likewise, the price of bananas can be dropped further to P1 cap, resulting in further increase in consumption of bananas to x1 cap. P1 cap plotted against x1 cap gives us the third point on the demand curve. Therefore, we observe that a drop in price of bananas results in an increase in quality of bananas purchased by an individual who maximizes his utility. The demand curve for bananas is thus negatively sloped. The negative slope of the demand curve can also be explained in terms of the two effects, namely substitution effect and income effect, that come into play when price of a commodity changes. When banana becomes cheaper, the consumer maximizes his utility by substituting bananas for mangoes in order to derive the same level of satisfaction of a price change, resulting in an increase in demand for bananas. Moreover, as price of banana drops, consumers' purchasing power increases, which further increases demand for bananas and mangoes. This is the income effect of a price change, resulting in further increase in demand for bananas. Law of demand. Law of demand states that other things being equal, there is a negative relation between demand for a commodity and its price. In other words, when price of the commodity increases, demand for it falls, and when price of the commodity decreases, demand for it rises, other factors remaining the same. Linear demand. A linear demand curve can be written as d of p equals to a minus bp, 0 less than equals to p less than equals to a by b, equals to 0, p greater than a by b, where a is the vertical intercept minus b is the slope of the demand curve at price 0, and the demand is a, and at price equals to a by b, the demand is 0. The slope of the demand curve measures the rate at which demand changes with respect to its price. For a unit increase in the price of the good, the demand falls by b unit. Figure 2.15 depicts a linear demand curve. Normal and inferior goods. The demand function is a relation between the consumer's demand for a good and its price when other things are given. Instead of studying the relation between demand for a good and its price, we can also study the relation between the consumer's demand for the good and the income of the consumer. The quantity of a good that the consumer demands can increase or decrease with the rise in income depending on the nature of the good. For most goods, the quantity that a consumer chooses increases as the consumer's income increases and decreases as the consumer's income decreases. Such goods are called normal goods. Thus, a consumer's demand for a normal good moves in the same direction as the income of the consumer. However, there are some goods that the demands for which move in the opposite direction of the income of the consumer. Such goods are called inferior goods. As the income of the consumer increases, the demand for an inferior good falls. As the income decreases, the demand for an inferior good rises. Examples of inferior goods include low quality food items like coarse cereals. A rise in the purchasing power income of the consumer can sometimes induce the consumer to reduce the consumption of a good. In such a case, the substitution effect and the income effect will work in opposite direction. The demand for such a good can be inversely or positively related to its price depending on the relative strengths of these two opposing effects. If the substitution effect is stronger than the income effect, the demand for the good and the price of the good would still be inversely related. However, if the income effect is stronger than the substitution effect, the demand for the good would be positively related to its price. Such a good is called a given good. A good can be normal good for the consumer at some levels of income and an inferior good for her at other levels of income. At very low levels of income, a consumer's demand for low quality cereals can increase with income. But beyond a level, any increase in income of the consumer is likely to reduce her consumption of such food items as she switches to better quality cereals. Substitutes and complements. We can also study the relation between the quantity of a good that a consumer chooses and the price of a related good. The quantity of a good that the consumer chooses can increase or decrease with the rise in the price of a related good depending on whether the two goods are substitutes or complementary to each other. Goods which are consumed together are called complementary goods. Example of goods which are complement to each other includes tea and sugar, shoes and socks, pen and ink, etc. Since tea and sugar are used together, an increase in the price of sugar is likely to decrease the demand for tea, and a decrease in the price of sugar is likely to increase the demand for tea. Similar is the case with other complements. In general, the demand for a good moves in the opposite direction of the price of its complementary goods. In contrast to complements, goods like tea and coffee are not consumed together. In fact, they are substitutes for each other. Since tea is a substitute for coffee, if the price of coffee increases, the consumers can shift to tea, and hence the consumption of tea is likely to go up. On the other hand, if the price of coffee decreases, the consumption of tea is likely to go down. The demand for a good usually moves in the direction of the price of its substitutes. Shifts in the demand curve. The demand curve was drawn under the assumption that the consumer's income, the prices of other goods, and the preferences of the consumers are given. What happens to the demand curve when any of these things changes? Given the prices of other goods and the preferences of a consumer, if the income increases, the demand for the good at each price changes, and hence there is a shift in the demand curve. For normal goods, the demand curve shifts rightward, and for inferior goods, the demand curve shifts leftward. Given the consumer's income and her preferences, if the price of a related good changes, the demand for a good at each level of its price changes, and hence there is a shift in the demand curve. If there is an increase in the price of a substitute good, the demand curve shifts rightward. On the other hand, if there is an increase in the price of a complementary good, the demand curve shifts leftward. The demand curve can also shift due to a change in the taste and preferences of the consumer. If the consumer's preferences change in favor of a good, the demand curve for such a good shifts rightward. On the other hand, the demand curve shifts leftward due to an unfavorable change in the preferences of the consumer. The demand curve for ice creams, for example, is likely to shift rightward in the summer because of preference for ice cream goes up in summer. Revelation of the fact that cold drinks might be injurious to health can adversely affect preferences for cold drinks. This is likely to result in a leftward shift in the demand curve for cold drinks. Shifts in the demand curve are depicted in figure 2.16. It may be mentioned that shift in demand curve takes place when there is a change in some factor other than the price of the commodity. Movements along the demand curve and shifts in the demand curve. As it has been noted earlier, the amount of a good that the consumer chooses depends on the price of the good, the prices of other goods, income of the consumer, and her taste and preferences. The demand function is a relation between the amount of the good and its price when other things remain unchanged. The demand curve is a graphical representation of the demand function. At higher prices, the demand is less, and at lower prices, the demand is more. Thus, any change in the price leads to movements along the demand curve. On the other hand, changes in any of the other things lead to shift in the demand curve. Figure 2.17 illustrates a movement along the demand curve and a shift in the demand curve. Market demand. In the last section, we studied the choice problem of the individual consumer and derived the demand curve of the consumer. However, in the market for a good, there are many consumers. It is important to find out the market demand for the good. The market demand for a good at a particular price is the total demand of all consumers taken together. The market demand for a good can be derived from the individual demand curves. Suppose there are only two consumers in the market for a good. Suppose at price P dash, the demand of consumer 1 is Q1 dash and that of consumer 2 is Q2 dash. Then the market demand of the good at P dash is Q1 dash plus Q2 dash. Similarly, at price P cap, if the demand of consumer 1 is Q1 cap and that of consumer 2 is Q2 cap, the market demand of the good at P cap is Q1 cap plus Q2 cap. Thus, the market demand for the good at each price can be derived by adding up the demand of the two consumers at that price. If there are more than two consumers in the market for a good, the market demand can be derived similarly. The market demand curve of a good can also be derived from the individual demand curves graphically by adding up the individual demand curves horizontally as shown in figure 2.18. This method of adding two curves is called horizontal summation. Adding up two linear demand curves. Consider, for example, a market where there are two consumers and the demand curves of the two consumers are given as D1 of P equals to 10 minus P and D2 of P equals to 15 minus P. Furthermore, at any price greater than 10, the consumer 1 demands 0 unit of the good, and similarly at any price greater than 15, the consumer 2 demands 0 unit of the good. The market demand can be derived by adding equation 2.14 and 2.15. At any price less than or equals to 10, the market demand is given by 25 minus 2p. For any price greater than 10 and less than or equal to 15, market demand is 15 minus p, and at any price greater than 15, the market demand is 0. Elasticity of demand. The demand for a good moves in opposite direction of its price, but the impact of the price change is always not the same. Sometimes the demand for a good changes considerably even for small price changes. On the other hand, there are some goods for which the demand is not affected much by price changes. Demand for some goods are very responsive to price changes, while demands for certain others are not so responsive to price changes. Price elasticity of demand is a measure of the responsiveness of the demand for a good to change in its price. Price elasticity of demand for a good is defined as the percentage change in demand for the good divided by the percentage change in its price. Price elasticity of demand for a good, E equals to percentage change in demand for the good by percentage change in the price of the good. Del Q by Q into 100 by del P by P into 100 equals to del Q by Q into P by del P, where del P is the change in the price of the good and del Q is the change in quantity of good. Suppose an individual buys 15 bananas when his price is rupees 5 per banana. When the price increases to rupees 7 per banana, he reduces his demand to 12 bananas. In order to find our elasticity demand for bananas, we find the percentage change in quantity demanded and its price using the information summarized in table. Note that the price elasticity of demand is a negative number since the demand for a good is negatively related to the price of the good. However, for simplicity, we will always refer to the absolute value of the electricity. तो ये इसका कैलकुलेशन है, आप देख सकते हैं. Therefore, in our example, as price of banana increases by 40%, demand for bananas drop by 20%. Price elasticity of demand E equals to 20 by 40 equals to 0.5. Clearly, the demand for bananas is not very responsive to a change in price of bananas. When the percentage change in quantity demanded is less than the percentage change in market price, EV is estimated to be less than 1 and demand for the goods is said to be inelastic at that price. Demand for essential goods is often found to be inelastic. When the percentage change in quantity demanded is more than the percentage change in the market price, the demand is said to be highly responsive to the change in market price and the estimated EV is more than 1. The demand for the good is said to be elastic at that price. Demand for luxury goods is seen to be highly responsive to changes in their market prices and EV greater than 1. When the percentage change in quantity demanded equals the percentage change in its market price, E is estimated to be equal to 1 and the demand for the good is said to be unitary elastic at that price. Note that the demand for certain goods may be elastic, unitary elastic and inelastic at different prices. In fact, in the next section, elasticity along a linear demand curve is estimated at different price and shown to vary at each point on a downward sloping demand curve. Elasticity along a linear demand curve. Let us consider a linear demand curve Q equals to A minus BP. Note that at any point on the demand curve, the change in the demand per unit change in the price del Q by del P equals to minus B. Substituting the value of del Q by del P in 2.16b, we obtain E equals to minus B into P by Q. Putting the value of Q, E D equals to minus BP by A minus BP. From 2.17, it is clear that the elasticity of demand is different at different points on a linear demand curve. At P equals to 0, the elasticity is 0. At Q equals to 0, elasticity is infinity. At P equals to A by 2B, the elasticity is 1. At any price greater than 0 and less than A by 2B, elasticity is less than 1. And at any price greater than A by 2B, elasticity is greater than 1. The price elasticities of demand along the linear demand curve given by equation 2.17 are depicted in figure 2.19. Geometric measure of elasticity along a linear demand curve. The elasticity of a linear demand curve can easily be measured geometrically. The elasticity of demand at any point on a straight line demand curve is given by the ratio of the lower segment and the upper segment of the demand curve at that point. To see why this is the case, consider the following figure which depicts a straight line demand curve Q equals to A minus BP. Suppose at price P0, the demand for the good is Q0. Now consider a small change in the price. The new price is P dash and at that price demand for the good is Q dash. Del Q equals to Q1 Q0 equals to CD and del P equals to P1 P0 equals to CE. Therefore ED equals to, और ये सब इसका फॉर्मूला दिया है तो हम लास्ट का देखते हैं. Thus ED equals to DA by DB. The elasticity of demand at different points on a straight line demand curve can be derived by this method. Elasticity is 0 at the point where the demand curve meets the horizontal axis and it is infinity at the point where the demand curve meets the vertical axis. At the midpoint of the demand curve, the elasticity is 1. At any point to the left of the midpoint, it is greater than 1 and at any point to the right, it is less than 1. Note that along the horizontal axis P equals to 0, along the vertical axis Q equals to 0 and at the midpoint of the demand curve P equals to A by 2B. Constant elasticity demand curve. The elasticity demand on different points on a linear demand curve is different, varying from 0 to infinity. But sometimes the demand curves can be such that the elasticity of demand remains constant throughout. Consider, for example, a vertical demand curve as the one depicted in figure 2.20a. Whatever be the price, the demand is given at the label Q bar. At price, a price never leads to a change in the demand for such a demand curve, and ED is always 0. Therefore, a vertical demand curve is perfectly inelastic. Figure 2.20b depicts a horizontal demand curve where market price remains constant at P bar. Whatever be the level of demand for the commodity at any other price, quantity demanded drops to 0 and therefore ED equals to infinity. A horizontal demand curve is perfectly elastic. Figure 2.20c depicts a demand curve which has the shape of a rectangular hyperbola. This demand curve has a property that a percentage change in price along the demand curve always leads to equal percentage change in quantity. Therefore, ED equals to 1 at every point on this demand curve. This demand curve is called the unitary elastic demand curve. Factors determining price elasticity of demand for a good. The price elasticity of demand for a good depends on the nature of the good and the availability of close substitutes of the good. Consider, for example, necessities like food. Such goods are essential for life, and the demand for such goods do not change much in response to changes in their prices. Demand for food does not change much even if food prices go up. On the other hand, demand for luxuries can be very responsive to price changes. In general, demand for a necessity is likely to be price inelastic, while demand for a luxury good is likely to be price elastic. Though demand for food is inelastic, the demands for specific food items are likely to be more elastic. For example, think of a particular variety of pulses. If the price of this variety of pulses goes up, people can shift to some other variety of pulses, which is a close substitute. The demand for a good is likely to be elastic if close substitutes are easily available. On the other hand, if close substitutes are not available easily, the demand for a good is likely to be inelastic. Elasticity and expenditure. The expenditure on a good is equal to the demand for the good times its prices. Often it is important to know how the expenditure on a good changes as a result of a price change. The price of a good and the demand for the good are inversely related to each other. Whether the expenditure on the good goes up or down as the result of an increase in its price depends on how responsive the demand for the good is to the price change. Consider an increase in the price of a good. If the percentage decline in the quantity is greater than the percentage increase in the price, the expenditure on the good will go down. For example, see row 2 in table 2.5, which shows that as the price of the commodity increases by 10%, its demands drop by 12%, resulting in a decline in expenditure on the good. On the other hand, if the percentage decline in quantity is less than the percentage increase in the price, the expenditure on the good will go up. And if the percentage decline in quantity is equal to the percentage increase in the price, the expenditure on the good will remain unchanged. Now consider a decline in the price of the good. If the percentage increase in quantity is greater than the percentage decline in the price, the expenditure on the good will go up. On the other hand, if the percentage increase in quantity is less than the percentage decline in the price, the expenditure on the good will go down. And if the percentage increase in quantity is equal to the percentage decline in the price, the expenditure on the good will remain unchanged. The expenditure on the good would change in the opposite direction as the price change if and only if the percentage change in quantity is greater than the percentage change in price. That means if the good is price elastic, the expenditure on the good would change in the same direction as the price change if and only if the percentage change in quantity is less than the percentage change in price. That means if the good is price inelastic, the expenditure on the good would remain unchanged if and only if the percentage change in quantity is equal to the percentage change in price. That means if the good is unit elastic. Rectangular hyperbola. An equation of the form xy equals to c, where x and y are two variables and c is a constant. giving us a curve called rectangular hyperbola. It is a downward sloping curve in the xy plane as shown in the diagram. For any 2 points P and Y on the curve, the areas of the two rectangles OY1 PX1 and OY2 QX2 are same and equal to C. If the equation of a demand curve takes the form PQ equals to E, where E is a constant, it will be a rectangular hyperbola where price P times quantity Q is a constant. With such a demand curve, no matter at what point the consumer consumes, her expenditures are always the same and equal to E. Relationship between elasticity and change in expenditure on a good. Suppose at price P the demand for a good is Q, and at price P plus del P the demand for the good is Q plus del Q. At price P the total expenditure on the good is PQ, and at price P plus del P the total expenditure on the good is P plus del P whole into Q plus del Q. If price changes from P to P plus del P, the change in the expenditure on the good is P plus del P whole Q plus del Q minus PQ equals to Q del P plus P del Q plus del P del Q. For small value of del P and del Q, the value of the term del P del Q is negligible, and in that case the change in the expenditure on the good is approximately given by Q del P plus P del Q. Approximate change in expenditure equals to del E equals to Q del P plus P del Q equals to del P whole Q plus P del Q by P into del Q by del P equals to del P whole into Q whole 1 plus Q del Q by del P Q P by Q equals to del P whole into Q1 plus ED. Note that if ED less than minus 1, then Q1 plus ED less than 0, and hence del E has the opposite sign as del P. If ED greater than minus 1, then Q1 plus ED greater than 0, and hence del E has the same sign as del P. If ED equals to minus 1, then Q1 plus ED equals to 0, and hence del E equals to 0. तो ये है इस चैप्टर का समरी और ये है इस चैप्टर का एक्सरसाइजेस। तो इसी के साथ हमारा ये सेकेंड चैप्टर कंप्लीट हो गया है। तो अगर आप चैनल पर नए हैं तो चैनल को सब्सक्राइब कर दीजिए और नोटिफिकेशन आइकन पर क्लिक कर दीजिए ताकि आपको सारे वीडियोस के अपडेट मिल सकें। साथ ही अगर आपको वीडियो अच्छा लगे तो लाइक कर दीजिए और अपने दोस्तों के साथ शेयर कीजिए ताकि उन्हें भी हेल्प हो सके। तो हमारा ये वीडियो यहीं तक था। थैंक यू, थैंक्स फॉर वॉचिंग।